All right, gang, Math 6610. The purpose of this video, I need more coffee, is to give you some marginal means uh, on the left. And what we're going to assume here is a fictional example, but we're going to assume that we have a couple of districts, A and B, and we have two online or two delivery methods, instructional delivery methods, either face-to-face or online. And we're comparing some sort of score, some sort of average on the score. So the very first relationship that we have is pretty non-interesting. The means for face-to-face are the same for District A and B, and the means for online are the same for districts A and B. So the marginal means are going to be the same as well. We get something kind of interesting here. District A, we would, of course, have an average of 14 for face-to-face. Average B, we would have, see if I can connect those. My big fat hand gets in the way. So the online would look that way, and imagine just doing that again. It'd be kind of cool if I had different colors, but I don't. So there's two lines there, pretend. And so we would not have statistically significant differences for District A versus District B. We would not have statistically significant difference for instructional delivery, and we would not have statistical significance for the interaction. Now, the way and let me pump the brakes here. What we're assuming is that, just for the sake of this, the narrative here is that a difference of 2 or more indicates statistical significance. So the way we look at the interaction is we go from District A to District B for face-to-face, so there's no change, so we have a 0. And from here, 14 to 14, there's no change, so 0 to 0 is no change. So our interaction is not statistically significant. Now, it should be no surprise that if we have our marginal means plot and we have our interaction plot, then, or if we have our marginal means, I should say, in our interaction plot, then it all kind of makes sense. But I'm trying to get you to a point, what if you have only your interaction plot? How do you determine statistical significance of your main effects and your interaction effects? So that's kind of the broader goal of this video. Now, the second example, for face-to-face, we have 14 for District A, and we have 14 for District B. And then for online, we have 18 and 18. For online. Now, what we have here is the lines don't intersect, so the interaction effect is not statistically significant. But how do we know from just the plot? In the absence of the information that we have to the left for number 2, how would we know that we have statistical significance across instructional delivery and not District A, District B? Well, if I come to District A, District B, and I look at the mean of these two, I get a 16. And if I look at the mean of these two, I get a 16. No difference, so we do not have statistical significance. But if I imagine this line coming right to the center, which would represent the mean of this line, well, again, kind of redundant there because it's a horizontal line, so we'd have 18, and we would have a 14 here, so the difference here is greater than 2, so I would have statistical significance from online to face-to-face. Now, compare that to number 3. So number 3, we get into a situation where we do not have statistical significance across the instructional delivery, but we have statistical significance from District A to District B. So what that would look like for District A, we would have an 18. District B, we would have a 14. and see if I can draw a straight line between there. So this would be face-to-face. And it turns out that the face-to-face would also, or I'm sorry, the online would also be the same line. So you can probably see from this, again, we don't have intersecting lines. Well, we have completely intersecting lines, but we don't have lines that cross at a particular point. And you can see where District A would have a mean of 18. District B would have a mean of 14, no variation there, so the difference is greater than 2. So this difference is statistically significant, but that midpoint for line 1 and midpoint for line 2 are the same. Now we get into, I think, a little bit more interesting situations where we get into, and again, let me go back up here. The interaction is not statistically significant because 18 minus 14 is 4. 18 minus 14 is 4. There's no difference in 4 and 4, so we do not have statistical significance for the interaction. Now, for the fourth plot, we get into a little bit more interesting. So face-to-face is 16, and District B is 12. And District A is 20, and District B is 16. So is the interaction statistically significant? No, because the lines don't cross. Also, 16 minus 12 is 4. 20 minus 16 is 4. No difference in the interactions, right? But we have a statistically significant difference in both the instructional design or instructional delivery and the district. Now, how do we know that from this? Well, if we look at District A, we have a mean of what, from 20 to 16. So we have a mean of 18, right? And looking here, we have a mean of 14, so the difference in 18 and 14. Now, if we come to the center of this line, we get the mean of it. Come to the center of this line, we get the mean of it. The mean here would be 14 and 18. So again, we have the same difference. But again, the lines do not cross, so we do not have statistical significance for the interaction. Well, you probably know what's coming up, right? Let's look at number 5. So number 5, we can see that the difference in face-to-face and online is not statistically significant. The difference in district is not statistically significant. But when we look at the interaction, we go from 14 to 18, right? Minus 4. We go from 18 to 14 plus 4. There's 8 units difference greater than 2. So we have a statistically significant interaction. So what's that going to look like? Well, face-to-face, we have 14 for District A, and District B, we have 18. It's hard to draw again because my big fat hand gets in the way. Then for District A, for online, we have 18, and District B, we have 14. Now, if you're seeing that without the information to the left, how do you know that we have a significant interaction, but the main effects are not significant? Okay, look at the mean. Look at the mean. They're the same, right? Come to the midpoint of that line. Come to the midpoint of that line. That's the mean there. Same value. No difference. Not statistically significant. But because the lines intersect, A cross B in general would have a p-value less than 0.05. Now, keep in mind that although interaction plots are extremely helpful and informational, contain a lot of information, we don't throw the baby out with the bathwater here and forget that the primary way of measuring statistical significance is still with the f-statistic and the p-value. All right, moving into plot number 6. So what do we have? Well, we have statistical significance over Instructional delivery, 12 to 16 is -4, 16 or 20 to 16 is +4. So we're going to have a statistically significant interaction and a statistically significant main effect, or one of them is. Now, what's this going to look in the interaction? So District A will start out at 12, and District B will go to 16. So this is for the face-to-face. And then for the online, we have a 20 and we have a 16. And you actually see this a lot. You see this form a lot. And so what do we know? What do we know that we have an average here of 16. We have an average here of 16. So from District A to District B, there would be no statistically significant difference. If I come to this point, midpoint, then these means comparing across online and face-to-face, the instructional design, instructional delivery, I don't know why I keep calling it instructional design, would be statistically significant. Because these lines intersect, then A cross B, or the interaction, would be statistically significant. So you're probably getting pretty good at this by now. There's just there's not a lot to it, but it's something that's extremely important. Therefore, I think it's worth taking the time in an instructional video to look at the different possibilities. So relationship number 7, what's going on there? Well, first of all, we can see that we do not have statistical significance across instructional delivery. We have statistical significance over District A and B. This difference is 0. This difference is -8, so there's more than a 2-point difference. So we have a significant main effect in a district, and we have a significant interaction. So what's that going to look like? District A, we will have 16. In District B, we will have 16. And in District A, we will have a 20. In District B, we'll have a 12. It's hard to draw. I probably should have gotten a ruler, but whatever. So again, from here to here is a mean, from here to here is a mean, so we have statistical significance. Come to the midpoint. If I'd drawn them correctly, they would intersect at the midpoint, no difference, but because the two lines intersect, we have statistical significance over the interaction. Now, you probably know what's coming up for the 8th one. So we're going to have statistical significance on both main effects, and 0 -8, we have statistical significance for the interaction. So that's going to look like District A will go from 12 to 12. So this is for the face-to-face. And then we'll go from 20 to 12. For the online. Now, again, take the mean difference, take the midpoint, the means are different. Because these two lines intersect, the interaction is statistically significant. Now, let me just throw one at you that doesn't have the information at the left, the marginal means. What could we determine here? So this has something to do with food quality and whether the person was infected or uninfected, the number of offspring. I'm really not sure what's being measured here. I'm more interested in just the graph. So let's say that we have food quality and we have the other measurement, and then of course we have food quality intersected with the infected or uninfected. So what's up? Definitely yes. because we have intersecting lines. You might say, well, they don't intersect. Well, they will, right? Do we have significant difference here? Well, come to the mean. Come to the mean. So this mean would be about, I don't know, 28 maybe. And this mean would be about a 10. So if statistical significance is more than 18 points, then we have statistical significance. Now let's look at the mean, the other comparison of means. Well, come to the center. Come to the center is this difference. This is about a 40. This is about, who knows, 5. So if we have a 35 difference, if that represents a difference that's statistically significant, then we have, so I am betting that, again, you got sample size issues and standard error and different things. But based on the, because again, I don't know the threshold for statistical significance. If the threshold is 2 points as it was previously, then clearly this main effect is statistically significant. This main effect is statistically significant, and the interaction, of course, is significant. Now, if the threshold is 20-point difference, then I do not have statistical significance in this main effect. I do in the other main effect, and I certainly do in the interaction. All right, hate to beat a dead horse, but I want you to be thoroughly introduced to interaction plots. And I'll show you in a future video, probably the next video, how we create an interaction plot from data using R. All right, so take care.